Hello and welcome to Startup Hack. Today we are going to talk about how to build a URL shortener with .NET. So let's jump right in. Make sure to check out the link down below because we always provide the code samples that you can pull down and follow along so you can see in our project. Alright, let's start with the URL shortener system design. Here's a high-level system design for our URL shortener. We want to expose two endpoints, one to shorten a long URL and the other to redirect users based on a shortened URL. The shortened URL are stored in a PostgreSQL database. In this example, we can introduce a distributed cache like Redis to the system, improve read performance. We first need to ensure a large number of shorter URLs. We are going to assign a unique code to each long URL and use it to generate the shortened URL. The unique code length and set of characters determine how many short URLs the system can generate. We will discuss this in more detail when we implement unique code generation. We are going to use the random code generation strategy. It's straightforward to implement and has an acceptably low rate of collisions. The trade-off we're making is increased latency, but we will also explore other options. Do you want to earn $100,000 a year? Do you want to become a software developer within just 3 months? With our amazing course and awesome tutors, you never have to worry about getting stuck. We help students to learn skills that companies want to hire. We are Startup Hack. Don't forget to subscribe our channel. So let's get started. Okay, now let's start by figuring out what we will store in the database. Our data model is straightforward. We have a shortened URL class representing the URL stored in our system. The class includes properties for the original URL, long URL, the shortened URL, short URL, and a unique code that represents the shortened URL. The ID and created on UTC fields are used for database and tracking purposes. The users will send the unique code to our system, which will try to find a matching long URL and redirect them. In addition, we will also define an entity framework application DB context class, which is responsible for configuring our entity and setting up our database context. I'm doing two things here to improve performance: configuring the code maximum length with has max length, defining a unique index on the code column. A unique index shields us from concurrency conflicts, so we will never have a duplicate code values persisted in the database. Setting the maximum length for this column saves storage space and its requirement for indexing string columns in some databases. Note that some databases treat strings in a case-sensitive way. This severely reduces the number of available short URLs you want to configure to the database to treat the unique code in a case-sensitive way. Now, unique code generation. The most crucial part of our URL shortener is generating a unique code for each URL. There are few different algorithms you can choose to implement this. We want an even distribution of unique codes across all possible values. This helps to reduce potential collisions. I will implement a random unique code generator with a predefined alphabet. It's simple to implement and the chance of collision is relatively low. Still, there are more performance solutions than this, but more on this later. Let's define a short link setting class that contains two constants. One is for defining the length of unqualified code we will generate. The other constant is the alphabet we will use to generate the random code. The alphabet has 62 characters, which gives us 7 possibly unique code combination. If you are wondering, this 3521 614 606 208 combinations is spelled out 3,521,614,606,208. Those are quite few unique codes, which will be enough for our URL shortener. Now let's implement our URL shortening service, which handles generating unique codes. This service generates a random string of specified length using our predefined alphabet. It checks against the database to ensure uniqueness. So here's example. The downside of this implementation is increased latency because we are checking each code we generate against the database. An improvement point could be generating the unique codes in the database ahead of time. Another improvement point could be using a fixed number of iterations instead of an infinite loop. In case of multiple collisions in a row, the current implementation would continue until a unique value is found. Consider throwing an exception instead after a few collisions in a row. Now that our core business logic is ready, we can expose an endpoint to shorten URLs. We can use a simple minimal API endpoint. This endpoint accepts a URL, validates, and then uses the URL shortening service to create a shortened URL, which is then saved to database. We return to full shortened URL to the client. There's a minor race condition here as we generate unique code first and then insert it into database. A concurrent request could generate the same unique code and insert it into database before we complete our transaction. However, the chances of this happening are low, so I decided not to handle that case. Remember that your unique index in the database is still guarding us against duplicate values. So here's an example. The second use case for a URL shortener is redirection. When accessing a shortened URL, we will expose another enable API endpoint for this feature. The endpoint will accept a unique code, find the respective shortened URL, and redirect the user to original long URL. You can implement additional validation for the specified code before checking if there is a shortened URL in the database. This endpoint looks up the code in the database and if found, redirects the user to the original long URL. The response will have 302 found status code per the HTTP standards. Thank you for watching this video. We have covered the key components of building URL shortener using .NET. You can take this further and implement the improvement points for a more robust solution. So don't forget to subscribe our channel and hit the bell icon for latest updates. To joining our course, you can simply go to our website called startuphack.com. Thank you.